The contamination of air with chemicals, smoke, dust particles, and disease-causing agents is called air pollution.
No wonder I have been coughing all day. We should stop polluting the air. But before that, let's find out the causes.
Burning of fossil fuels contributes to the addition of suspended, unburnt hydrocarbon particles into the air. Fuels like coal and petroleum also release nitrogen and sulfur oxides. These oxides of nitrogen and sulfur dissolve in air and form acid rain. Breathing of this polluted air causes allergies, cancer, and heart diseases. Now, let us look at another natural resource, water. It is found on the Earth's surface, under the ground, and in the atmosphere as water vapor. Most of the water on the Earth's surface, found in seas and oceans, is saline. Fresh water is found frozen at the 2 poles, on snow-covered mountains, and in rivers and lakes. The availability of water is one of the main factors that decide the nature of vegetation and diversity of life in an area. Water is essential for the survival of plants and animals, as cellular processes take place in a water medium. The contamination of water by sewage, chemicals, detergents, fertilizers, and other harmful substances is called water pollution. Let's take a look at the causes of water pollution. Industry chemicals and urban sewage are dumped into rivers and lakes. Fertilizers and pesticides used in farms dissolve in water. Dissolved oxygen is needed by aquatic animals. A rise in the water temperature removes the dissolved oxygen and causes the death of many aquatic animals.
Look at what we have done again. Very soon, there'll be no clean water to drink.
Like air and water, soil is another important natural resource that supports life. You must have seen different types of soil, but do you know what it really is? Soil contains soil particles, humus, and living organisms. Humus determines the quality of soil. Over millions of years, rocks on the Earth's crust have been broken down by physical, chemical, and biological processes to make soil. Sun, water, wind, and living organisms are the factors that help in the making of soil. Due to uneven contraction and expansion, rocks crack and break into smaller particles of soil. Water logged in the cracks of rocks freezes, and the cracks widen to eventually break into soil. Living organisms like lichens grow on the surface of rocks and release chemicals that powder rocks to soil. The flowing water in rivers breaks the hard rock and forms soil particles. Strong winds erode rocks and carry sand from one place to another. The addition of substances that adversely affect soil fertility is called soil pollution.
It seems we didn't spare soil too. How did we do it?
Use of fertilizers and pesticides destroy soil structure by killing microorganisms and earthworms. Deforestation leads to soil erosion. Fine particles of soil are also carried away by water and wind.
Soil forms very slowly. Around 1 centimeter of soil is formed in 500 years. So it is important to conserve soil.
What comes first, the nut or the tree? That may be a tough call to take. Whether it's the seasons or life on Earth, nature works in cycles. In this lesson, you will learn about biogeochemical cycles, the greenhouse effect, and the ozone layer. By the end of this lesson, you will be able to define biogeochemical cycle, describe the water cycle, describe the carbon cycle, describe the nitrogen cycle, describe the oxygen cycle, explain the greenhouse effect, describe the ozone layer, and explain the consequences of the depletion of the ozone layer. The cycling of chemicals between the biological and the geological world is called biogeochemical cycle. The biotic and abiotic components of the biosphere constantly interact through these cycles. During these interactions, there is a transfer of nutrients between living organisms or bio and non-living environment or geo.
Hi there, I'm Oxy. I shall join you on this journey to explore the different biogeochemical cycles. Do you know the 4 most important biogeochemical cycles? They are the water, nitrogen, carbon, and oxygen cycles. We know that water evaporates from water bodies. But have you ever seen seas and oceans drying up? Well, they never do, thanks to the water cycle. Let's see how.
Water evaporates from the water bodies and returns as rain, which in turn flows back into the seas via rivers. This cycle of water between the land, the ocean, and the atmosphere is called the water cycle. Let's take a closer look at the cycle. When the oceans are heated during the day, water enters the atmosphere as water vapor by the process of evaporation. There is another way in which water evaporates into the atmosphere. This happens through transpiration. Water from plants evaporates as vapor into the atmosphere through stoma in the leaves and stems. This water vapor in the atmosphere changes to water droplets and collects to form clouds. This process is called condensation. Sea breeze moves these clouds and carries them over the land, where they break into rain, snow, or fog. This is called precipitation.
Wow, it's raining here. Do you know what happens to the rainwater now? Where does it go?
Much of the rainwater flows into the water bodies and eventually runs off into the ocean. Some of it penetrates the Earth's surface and is logged as groundwater.
Now I get it. This is how water is maintained in the biosphere by the water cycle.